Good day, my listeners and viewers, home and abroad. Glad to be before you again today in another class. In our chemistry class today, what we are considering is water. Water, as we know, is a universal solvent in liquid form, although it can change states when the temperature changes. It is a colorless, odorless liquid, and has insipid taste. The word insipid means tasteless. Insipid means tasteless or uninteresting. Tasteless or uninteresting. So looking at the characteristics of pure water, what makes a water pure? Number one, pure water boils at 100 degrees Celsius, which is equivalent to 373 Kelvin. Secondly, is soft. So pure water is soft. And thirdly, has no dissolved substance in it. No dissolved substance in it. So that's what makes a water pure. There's even between pure water and potable water. The water that is bottled, that is in sachets, is not pure water. It's rather called potable water. Sachet water or bottled water. Bottled water is called potable water. Potable water. So stop calling bottled water or sachet water pure water. They are not pure water. Why? They have dissolved substances in them. Most of them are chlorinated. Pure water will have no dissolved substance. Has no dissolved substance in it. No dissolved substance in it. And when I mean dissolved substance, it can be solid, it can be liquid, it can be gas. If the water has CO2 dissolved in it, it's no longer pure water. It has turned to carbonated water. So the dissolved substance can be solid, liquid, or gas. So when you talk about pure water, it boils at 100 degrees Celsius temperature. If it's not boiling at 100 degrees, it will boil at narrow, around 99.9 degrees Celsius, which is approximately 100 degrees Celsius. It is soft, which means it forms lather easily with soap and has no dissolved substance in it. No solid is dissolved in it, no liquid is dissolved in it, and no gas is dissolved in it. So when you talk about pure water, rainwater, and distilled water, both are pure water. Rainwater and distilled water both are pure water. Rainwater is soft as well as distilled water. So rainwater can as well be regarded as distilled water. Rainwater is as a result of evaporation from water bodies, then condensation, precipitation after saturation. So it is the cloud that distills rainwater. So rainwater is pure, provided it has not touched other items like the roofing sheet, does not touch a dirty containers and the like. Then distilled water, that is water that is produced through the process of distillation, evaporation and condensation. So when you talk about pure water, rainwater and distilled water are pure water. Structure of water. As we know, water is a compound because it's a product of chemical combination, chemical reaction, whereby a new substance is produced, so it's a compound. And as a compound, it consists of 1 molecule of hydrogen, 1 molecule of hydrogen, 1 molecule of hydrogen, that is H2, which is equal to 2 atoms. 2 atoms of hydrogen, and then 1 atom of oxygen, which is O. So the chemical formula for water is CH2O. I mean, that's H2 rather. Chemical formula for water is H2O liquid. So, how does water get its structure? We have 2 hydrogen bonded to 1 oxygen. 2 hydrogen atoms bonded to 1 oxygen atom to give us the structure of water. So let's look at it. Atomic number. The atomic number of hydrogen is 1. That of oxygen is 8. So we can distribute electronic configuration of oxygen is going to be 2, 2,6. So, which means we are going to have oxygen at the center. In the outermost shell of oxygen, we have 6 electrons. 6 electrons. 1, 2, 3, 4, 5, 6. We have 6 electrons in the outermost shell of oxygen. In the chemical reaction, oxygen we want to attain octet state. That is, it needs 8 electrons in its outermost shell. While hydrogen, we want to attain duplex state. Duplex state. Hydrogen wants to attain duplex state, which means it is to have 2 electrons in its outermost shell. But as it has 1 electron, while oxygen has 6 electrons. So there is going to be sharing of the outermost electron, so that they can attain a stable state. And that is what is regarded as covalent bonding. Covalent bonding, as you know, involves sharing. So one hydrogen will share 1 electron with water. Another hydrogen will share 1 electron with oxygen in order to form water. So that means the structure of water molecule will now be oxygen at the center, hydrogen here, hydrogen here. We have unshared pair of electrons. These unshared pair of electrons are regarded as lone pair. Lone pair electron. This is another lone pair electron. So the unshared electron are regarded as lone pair. So we have two lone pair attached to the oxygen in water molecule. So the repulsion between the two unshared lone pair of electron gives hydrogen is V-shape. Give hydrogen is V-shape. So the shape of, give water is V-shape rather. The repulsion between the two or true unshared lone pair electron gives water is V-shape. So the shape of water is V-shape. So water molecule is V-shaped. So between the two hydrogens, we have a bond of 104.5 degrees. So you come across the question that asks you what is the shape of water molecule. The shape of water molecule is V-shaped. And what's responsible for that? The repulsion between the two unshared lone pairs of electron attached to oxygen in water molecule, and the bond between the two hydrogen attached to oxygen in water molecule is 104.5 degrees. Alright, we are looking at a dimerization. It is the interaction between two identical molecules of the same substance. The interaction between two identical molecules of the same substance is regarded as dimerization. And it occurs in water when the hydrogen atom of water molecule joins or bonds to the highly electronegative oxygen atom of another molecule. So when we talk about electronegative elements, there are usually three electronegative elements, which are fluorine, nitrogen, and oxygen. So hydrogen usually bonds with these three elements. Out of these three elements, the most electronegative is fluorine. Fluorine is the most electronegative. So when hydrogen bonds with any of these three elements, there is going to exist an intramolecular bond that is called hydrogen bond. So when we have water molecule H2O, oxygen at the center, H2O. And then you have another water molecule, H2O. So there is going to be an interaction between this oxygen and this hydrogen. Between this hydrogen and oxygen. So let's say we have another one here. Oxygen at the center here. Oxygen here. Hydrogen here. Hydrogen here. There will be an interaction between this hydrogen and oxygen. So those dotted lines shows the hydrogen bonding. So when you have molecule of water joining with another molecule of water, that is regarded as dimerization. So this is an illustration of dimerization. Hardness of water. Hardness of water is due to dissolution of rocks and soil minerals in water and some atmospheric gases in water. So when you talk about hardness of water, usually we have surface water. We also have underground water. Example of surface water are water that runs in rivers, stream, lakes, etc. Those are examples of surface water. And when you talk about underground water, these are the water underground, such as a well, borehole. These are underground water, as well as spring. Spring is another example of underground water. So in this underground water, we have dissolved minerals. Surface water, that's the water that runs on the soil, that run on the surface of the soil. While underground water are the water that you get by breaking through rocks. So soil contains mineral substance as well as rocks. And usually the mineral substance present are calcium, magnesium, as well as iron. So these three minerals are present in soil as well as in rock. So when water runs on the soil or water comes through the rock, you have these dissolved minerals, these elements dissolved in the water, and that results into hardness of water. So that makes the water to become hard. That will give us hard water, as contrary to soft water, which does not contain dissolved substances. So which means hard water, we have opposite of the characteristics of soft water. Hard water will not boil at exactly 100 degrees Celsius. It's either it boils at a lower temperature or higher temperature than 100. Hard water does not form lather easily with soap. And when you talk about hard water, it's not insipid taste. It usually have palatable taste of the mineral that is dissolved in it. So we are looking at hard water. Hard water is a type of water that does not form lather easily with soap. That is, it does not foam. Does not foam easily with soap. Other features or characteristics of hard water: does not boil at 100 degrees Celsius. That is, it can boil below or higher 100 degrees Celsius. Also has taste of the dissolved mineral in it. So when you talk about hard water, it has advantages and disadvantages. Advantages of hard water and disadvantages. Number one advantage of hard water is that it has palatable taste. The taste is interesting. It's not insipid like that of a soft water. Another advantage is that the minerals help in development of strong bones. Development helps in development of strong bones and teeth. Strong bones and teeth. Thirdly, it helps in formation of shells. Helps in formation of shells. Formation of shells. In animals like mollusks, like snail, corals, also in crustaceans like crabs. So hard water helps in formation of shells in snails, coral, also carapace in crabs. So talking about disadvantages of hard water, since it does not form lather easily with a soap. Number one, that means it's not economical. It's not economical because it wastes soap. It's not economical because it wastes soap. Since it does not form lather easily with soap. Secondly, it wastes time and energy. That means it will require time and energy before you can be done with what you are washing. So secondly, it wastes time and energy. Thirdly, it causes fouring of boilers and kettle. Causes fouring, F-U-R-R-I-N-G, fouring of boilers and kettle. Fouring of boilers and kettle. What do you mean by fouring of boilers and kettle? Sometimes when you boil water, after a while when the kettle is dry, you will notice white deposit like chalk on that kettle. The white deposit like chalk on the kettle or on the pot or on the boiling ring is as a result of the dissolved mineral inside the hard water, which has been decomposed by the action of heating. So it causes burning of boilers, which make them lose their refractive luster. Types of hardness of water. There are two types of hardness of water. We have temporary hardness of water. Temporary hard water. And we have permanent hard water. So those are the two types of hardness of water: temporary hardness and permanent hardness. When we talk about temporary hardness of water, it is due to bicarbonate of calcium, magnesium, or iron. Another name for bicarbonate is hydrogen triisocarbonate 4. So which means in temporary hard water, you can have calcium. This is 2 plus. So you can have calcium HCO3, calcium bicarbonate. You can have magnesium bicarbonate. carbonate or iron bicarbonate. So these are responsible for the temporary hardness of water. Why is it regarded as temporary? Because this bicarbonate can be broken down by the action of heat. They can be broken down by the action of heat. For example, CH, CO3, bracket 2, if we apply heat, will give us Ca, CO3 plus water plus CO2. So we can see that we have one calcium, two hydrogen, two carbon, we have 6 oxygen, 3, 4, 6. So that's the balance equation. So because this bicarbonate can be broken down, can be decomposed by action of heat, that's why it is regarded as temporary hard water. So what causes fouring of kettle and boiler is the deposition of this calcium carbonate. The deposition of calcium carbonate, magnesium carbonate, iron carbonate on the pot, on the kettle, on the boiler is what causes that white deposit on the boiler or kettle. And when you talk about permanent hard water, the hardness is due to the presence of chloride, nitrate, or sulfate of calcium, magnesium, or iron 2+ in water. So permanent hardness of water is due to the presence of chloride, nitrate, or sulfate of calcium, magnesium, or iron 2+ in water, which means in permanent hard water we can have calcium chloride, CaCl2, you can have calcium nitrate, you can have calcium sulfate, you can have magnesium chloride, you can have magnesium nitrate, you can have magnesium sulfate, we can have iron chloride, we can have iron nitrate, and we can have iron sulfate. So these are responsible for the permanent hardness of water, and usually they are not easy to break, to be decomposed. That's why they are regarded as the ion responsible, as the substance responsible for the hardness, permanent hardness of water.